And the board model that we are going to do now, that is going to be a bit later on.
Sir,
Yeah, tell me. Yes, Sabiha.
then I was watching the recording of the previous class because I was traveling और मैं क्लास टेन में करा था ना मैंने, तो उसका मैं रिकॉर्डिंग देखती थी सर। और मुझे ना आप वो जो सिंबल ए जेड प्रोटॉन न्यूट्रॉन का था ना, उसमें मुझे जेड माइनस एन और जेड प्लस एन का समझ में नहीं आ रहा था सर मुझे।
Sabiha, आपको ना थोड़ा रिपीट करना पड़ेगा because there is some disturbance from your voice. I could not understand much. I just understood that you did not understand a few lectures. Can you just readjust your mic or do something? Because too much noise with the voice.
Can you hear me now, sir?
Yeah, now it is much better. Yeah, tell me.
नहीं वो I didn't attend the previous class, तो I was
Okay.
मैंने उसका रिकॉर्डिंग देखा सर, वो समझ में आया। बट आप जो पार्ट में सिंबल ए जेड प्रोटॉन न्यूट्रॉन वगैरह करा रहे थे ना,
This part.
वो पार्ट में ना मुझे वो जेड माइनस एन और जेड प्लस एन का समझ में नहीं आया कि हम एन किसको ले रहे थे यहाँ पे करके।
This is the n negative charge, whatever the charge is there ना यहाँ पे. For an ion with n negative charge, number of electron is equal to z plus whatever the charge is. N is the charge, not neutron. ठीक है?
अच्छा, ओके ओके
ठीक है.
सर।
यहाँ पे लिखा ना for an ion with n negative charge, number of electron will be z plus n. N is the charge here. ठीक है?
यस सर।
So what I will do now, I will discuss first of all the discovery of fundamental particles, and then slowly we are also going to discuss the some important what I can say, some important data that we got and how did we get those data. एक तो general अभी आप लोग को बताएंगे हम, which is going to be useful that you can write in the examinations regarding the electron discovery, protons and neutron discovery. And then we are going to also look into the details of how the experiments were conducted in order to get, like, we are doing experiments in the macroscopic level, but we need the data of microscopic things such as electrons and protons and neutrons. Okay. So for that, it will be a bit intense, but initially whatever is needed for the CBSE 11th standard, that is going to be very easy. Okay. So please write the heading discovery of fundamental particles. So the topic, discovery of fundamental particles. Now, discovery of fundamental particles. First of all, we will talk about what are the fundamental particles? Electrons, that is E, which has a negative charge. Protons, will denote this as E positive. And neutrons. Okay, neutrons में हम n0 कर देते हैं, so that you will understand this is n0 means neutron, without any charge, are the fundamental particles. Are the fundamental particles. The first topic that we are going to take is the discovery of electron. Discovery of electron. You can also call this cathode ray experiment. Cathode ray experiment. Okay, please write till here. Assalamu alaikum, Shaima. Am I audible?
वालेकुम सलाम सर।
Shaima, what happened? Why are you late?
Sir, I lost track of time.
You lost track of time. क्या आप मतलब टाइम ट्रेवल कर रहे थे क्या आप? हाँ शायमा, were you doing a time travel? Yes, tell me.
No,
Lost
sir.
track of time. हाँ, ये टाइम ट्रैवल कर रहे हैं। इंडिया के 6:30 बजे आपको एक स्टेशन में रुकना था जहाँ पे आपको क्लास करनी थी, लेकिन आप आगे निकल गए टाइम से। जैसे कैसे भाई साहब, एक से एक रीजन है भाई। लॉस्ट ट्रैक ऑफ टाइम। चलिए जल्दी जल्दी लिखिए। देन वी विल एक्सप्लेन व्हाट इज द कैथोड रे एक्सपेरिमेंट। उसके बाद एक्सपेरिमेंट समझाएंगे। वंस आई एम एक्सप्लेनिंग द एक्सपेरिमेंट, यू आर नॉट गोइंग टू राइट एनीथिंग, ठीक है? आफ्टर दैट यू आर गोइंग टू राइट। इसको लिख लीजिए पहले। इलेक्ट्रॉन्स, प्रोटॉन्स एंड न्यूट्रॉन्स आर फंडामेंटल पार्टिकल्स, देन डिस्कवरी ऑफ इलेक्ट्रॉन और कैथोड रे एक्सपेरिमेंट। Shaima, I will be just waiting for you because I think most of the students they have done this. I mean not done this in the sense discovery of electron and cathode ray experiment वहां तक सबने लिख लिया होगा। ठीक। I hope you have written this down. No. So this is the setup for cathode ray experiment. Scroll up, अभी तक नहीं लिखा आपने, जल्दी लिखिए।
Answer.
ठीक है, ध्यान दीजिए। So this is the setup for cathode ray experiment. So what we are doing here is we have this blue thing, and this is a glass tube, ठीक है, जिसको CRT बोलते हैं, कैथोड रे ट्यूब, ठीक है, CRT. Now in this what we have done, we have one plate here that is black in color, and this plate, it is connected towards the battery from the negative end, and then this battery is further connected to another uh, metal, that is, we will call it anode because positive charge. यहाँ पे it is going to be positive charge. So why it is positive charge? Because it is connected to the positive end of the battery. This is negative charge because it is connected to the negative end of the battery. And here we are going to have a vacuum pump. What is vacuum pump? Vacuum pump is that it removes air. When you are going to remove air, there will be very low pressure. Why pressure exists? Because air, it is gas molecule. Gas has a tendency to exert pressure on the walls of the container. Okay. So vacuum pump से क्या होगा? You will have air at low pressure. You can never create anything which is like complete vacuum. At least here, it is not practical to create complete vacuum. There will be at least some air molecules with very low pressure. This is known as the discharge tube. This whole thing is known as what? Discharge tube. Achha. Now, when we attach this with a high voltage generator and when we switch this on, then what was seen is that there is a flow of electron. The flow of electron कैसे देखा? The flow of electron was seen like this. Let us suppose this is the anode, but थोड़ा सा हम यहाँ पे होल कर देते हैं, ठीक है? I hope you can see the white. When I have hole here, then what we can say, what we will see, one एक तो hole है, उसके बाद एक और चीज करना ये पड़ेगा, that we will apply here zinc sulfide, a coating of zinc sulfide. A very good property of zinc sulfide is that if electron or if any charged particle strikes on the zinc sulfide, it glows, it gives you green color. ठीक है? So what was seen that first of all electricity was running, then it was seen now electricity is running without any what? Without any conductor. We had very high voltage though. Okay, we had very high voltage. Without any conductor, the electricity was flowing. That means there are some charged particles inside the air. Another thing, what we saw was the charged particles, they were also traveling in a straight line. And it was showing some greenish glow on the zinc sulfide. Now, when it was showing greenish glow on the anode side, then we understood that when we put the zinc sulfide in this partner, the cathode was, there is no glow. With the same thing, we also had a hole in this cathode. We did not see any greenish glow in the cathode side. We only saw the greenish glow in the anode side. That means whatever charge particle is present, it is traveling from cathode towards anode. So if it is traveling from cathode towards anode, that means we will say that the charge particles is getting attracted by the positive end. If the charge particle is getting, attracted by the positive end, the charge particle will be negatively charged. Does that make sense? Electron तो अभी नाम नहीं दिया था उसको. It will be negatively charged. Make sense till here? Yes or no? Please tell me what was happening. First of all, there was a gas. It was enclosed at very low pressure in the discharge tube. ठीक है, and then we attached a high voltage generator. The voltage was approximately 10,000 volt. Some invisible rays, it originated from the cathode ray. ठीक है, from the cathode. Some invisible rays, it originated from cathode and towards the anode, and it produced a greenish type of glow when zinc sulfide was coated in the anode side. ठीक है. Now, this was the observation. From this observation, we will then write few conclusion points. ठीक है, so I will write each and every point. Don't worry about. ठीक है, so अभी आप एक काम कीजिए. You can leave the space for this whole setup, और इसको आपको बनाना है. ठीक है ना? Just take a screenshot. I will wait for 5 seconds for this. 5, 4, 3, 2, 1. I hope you have taken the screenshot. Now you are just going to write with me, and you will understand each point. Don't worry about it. ठीक है? If you don't understand, you can let me know, but hopefully you are going to understand. Very easy points. Please write with me. When a gas is enclosed at very low pressure, pressure is in the powers of 10 to the power minus 4 atm. What we feel is 1 atm, and we have to reduce it 10,000 times. 10 to the power minus 4 atm in discharge tube. In discharge tube, and is subjected to high voltage. Subjected to high voltage. The voltage that we have to give is approximately 10,000 volts. Okay, these values are not important for, but you need to write this in your note. Invisible rays originate from negative end. Negative end क्या है? Cathode. Anode. Anode क्या होता है? Positive end. ठीक है? Then you write producing a greenish glow. A greenish glow. Greenish glow behind perforated anode. I put it on the glass wall. The glass wall coated with zinc sulfide. Coated with zinc sulfide. Zinc sulfide. ठीक है, so this is what happened in the cathode ray experiment. Perforated के बारे में हम आपको बता देते हैं. See, whatever setup I have shown you now, this is side view. तो एनोड और कैथोड जो होगा ना, that if you see the anode from the front, है ना, फिर facing the anode, साइड में तो आपको ऐसा दिख रहा है, like this. The reason is because अगर आप फ्रंट में देखें ना, तो it will be circular. ठीक है, तो सर्कल को अगर आप टिल्ट कर दे तो एक ऐसा लाइन दिखेगी इस तरह से. If I tilt it some angle, ऐसा दिखेगा, right? That is why what we are seeing is simple one straight line, but it is actually circular ring type का structure है, coin type का structure है. इसको perforated मतलब you will have to put holes there. So what you can do, you can put a single hole like this in the anode side, ऐसे करके बीच में आपने एक hole कर दिया, and इस hole से बस आपको some electrons will pass through this, and it is going to give greenish glow. ठीक है, तो perforated होता है. Okay. Now we are going to write the characteristics of cathode. This was the observation. What are the conclusions from this observation? What we can draw the conclusion that we are going to do. Characteristics of cathode ray. अच्छा, cathode ray क्यों बोल रहे हैं इसको? Because these are originating from the cathode and traveling towards the. That is why we are calling cathode. You will write this point also. The first point will be, please write. They were called cathode ray because They originated from. Please write these things with me, okay? They originated from. They originated from cathode. They originated from cathode. Next point you are going to write. Next point we will write. They got deflected. These rays, they got deflected in the presence of magnet. Okay. Therefore, cathode ray has charge. Okay, actually, I will show this experiment. I think that will make you digest it more. Okay, so don't worry, I will show this complete experiment. Right, next point. Cathode ray travels from cathode, that is the negative terminal, to anode, that is the positive terminal, meaning cathode ray, is negatively charged. That is why it is attracted towards the positive terminal. Next point, cathode ray move a pinwheel if placed on their path. Therefore, if something can move ना, अगर आप समझिए जरा, जैसे let us suppose wind, right? Wind can make the fan, the blades of fan, the wind can make it move. So how is wind able to move the blades of fan? Wind, it has air. Air, it has oxygen, nitrogen, and mainly oxygen, nitrogen. There are many dust particles also. So all of these are particles which have mass, and with some speed, mass, and if there is acceleration, there will be force. Mass, if there is any velocity, this will also have momentum. So when something which has mass and it has velocity is striked upon something, then only what will happen? Some movement can take place. So if the cathode ray were moving first of all, so it is having some velocity or acceleration. Cathode ray moved a pinwheel. That means cathode ray are also what? Particles. Okay, so cathode ray moved a pinwheel if placed on their path. Therefore, cathode ray are particles. Are particles. The next point is when they fall on heavy metal, they produce X-rays. ठीक है, इसके बारे में हम लोग बाद में बात करेंगे, बस टेक्निक है. Next point is cathode ray travels in the speed of light. Cathode ray travel in the speed of I have to show you guys, no? Okay. Can you guys see the screen? disclaimer, the chemistry demonstration lab. Can you see this?
Yes, sir.
Yes, just give me a second. I'm pausing the recording here. ठीक है, because this YouTube video ये बाद में YouTube पे upload होगा. There can be some strike. ठीक है, so I'm pausing the recording. Just remind me, है ना, once the video is over, that you have to start the recording. ठीक है. Correct. I need to reshare my screen. ठीक है. No, I will tell you that charge to mass ratio. ठीक है, for cathode rays. For cathode rays, by the way, who did this experiment? ये मैंने लिखा है ना. So Thompson was the one. ठीक है, उसको बाद में लिखा देंगे, अभी की जगह नहीं है लिखाने का. But try to understand this part. We started with air. Don't write anything right now. Don't write anything. We started with air, and what we did for cathode ray, for air we calculated the charge to mass ratio. Charge to mass ratio. ठीक है. So Q by N. How did we do that? You will come to know. ठीक है, you will come to know. Charge to mass ratio. ठीक है. Charge to mass ratio we calculated. Then we did first for air. Then we added hydrogen gas, and we calculated the charge to mass ratio. Then we added nitrogen, not we, Thomson, nitrogen. Then we did for helium. Then we did for oxygen. So for all of these different gases, the charge to mass ratio, he did not calculate charge, then calculated mass, and then divided it. He did not do it that way. He did charge by mass because he was able to calculate this ratio itself, and he could not calculate the charge Alexa and the mass Alexa. Okay, so what he saw was charge to mass ratio was same. This ratio was. That means all of these different type of gases are giving the same cathode rays. That means the cathode rays, the charge to mass ratio or the cathode rays, it does not depend on the type of gas we are using. Right? So this was one of the observation from Thomson. First, you will write something that charge by mass ratio of cathode rays was found to be independent of the gas used in discharge tube. Okay, used in discharge tube. Now we will write by, please write this by above observations. J.J. Thomson suggested the following. Okay. Now we tried a lot of experiment in order to understand, like if there is something negative, there should be also something positive. Okay. But he could not devise any experiment to get the protons. Right? Did not get any positively charged rays. So what J.J. Thomson said or concluded from his observations was that he was getting charged particles which were negatively charged. So obviously the structure of atom would be something like this, that atoms, it has negative charges, right? Now negative will be what we can say, negative will be balanced by the positive charge. So he said that there is an overall positive charge in the atom. Why did he say overall positive charge? Because he did not get any cathode rays. Okay. He did not get any, sorry, anode rays. Anode rays कुछ नहीं मिला उसको. Then he said what? There will be an overall positive charge, and in this positively charged atom, there are electrons embedded. And when we are going to apply a high voltage, then these electrons, they can escape this particular, they can, because of the positive charge is attracting the negative charge. But if we apply a voltage such that it is more than the force between positive and negative charges, so the electron will escape out the atom and then it will go towards the anode. Okay. So this was the Thomson model. I hope you have seen this. He said that atoms are positively charged sphere with negatively charged electrons in it. Electrons तो उन्होंने पता लगा गया that it is a particle, ठीक है? And because it looks like plum pudding, that is a British dish pudding जो होता है, so that is why this model is also known as plum pudding model. This model, this is the model of atom. This model of atom is aka plum pudding model. All of you guys understood what happened? Yes or no, please tell me.
Yes, sir.
Yes, sir.
Yes. Now, next was the discovery of proton. So I hope you have written till here. This this model of atom is also known as, aka, also known as plum, plum, pudding, pudding, model. Okay, Zainab?
Yes, sir.
Next experiment was second one, that is proton. The discovery of proton. So यहाँ पे ना we have discussed the J.J. Thomson model. So for J.J. Thomson, when we'll be discussing the models of atom, we'll be only writing the drawbacks of J.J. Thomson model. ठीक है? So this is the only thing from J.J. Thomson model. ठीक है? That these are positively charged spheres with negatively charged electrons in it. Discovery of proton, it was done by Goldstone. इसमें आप लोग को एक्सपेरिमेंटल सेटअप अभी आप उसका हम लोग अच्छे से पढ़ेंगे तो उसके बाद इसको देखेंगे. You write here discovered by Goldstone from observation of anode ray experiment. Now, why J.J. Thomson was not able to get anode rays, but Goldstein, he got anode rays. The reason was time. So Thomson, at that time, there was some limitations on the power or the voltage of electricity that you can generate. And as time passes by, that limitations, it is being stretched, right? For example, think about the phones that we have right now, and think about the phones that was approximately 20 years before. So before 20 years, like we had very minimum, like the phone was only able to do something. Right now, phone can do a lot of things that a computer can also do, right? So it is almost getting similar to what a computer can, right? So similarly, the tech at the time of Thomson was not enough to generate voltage so that the protons can also be extracted from the atom. But at the time of Goldstein, as the generation passed, and we had generators which can generate a lot of voltages. That is why even the protons could escape out the atom. Now, what the main observation from the anode ray experiment was? The charge to mass ratio. Okay, Q is for charge, M is for mass. Charge to mass ratio, Q by M, of anode rays was found to be very less than that of than that of cathode rays. Okay. Now, because it is anode rate, it will be positively charged. Okay. The cathode rays is negatively charged. So they assume that whatever negative charge the atom had, the same amount of positive charge the atom will have because atom is neutral. So the Q will be same, but the Q by M ratio was coming out to be very less. That means mass of the anode rays should be much higher. Okay. So Q by M ratio of anode rays was found to be very less than that of cathode rays, meaning mass of anode rays was much higher than the mass of cathode. So anode rays, because it has positive charge, we call it proton, and that is why we can say that mass of proton was greater, much greater than mass of electron. Okay. Next observation was found out that the charge to mass ratio of anode rays, I'm writing AR, was found to be dependent on the gas used. So if we used hydrogen, then that was getting charged by mass ratio very large. Okay. And that was highest. And then only we came to know that hydrogen is going to be the lightest element. Hydrogen gas will be the lightest gas, rather, not element, the lightest gas. As we used heavier and heavier element, the charge to mass ratio, it got lesser and lesser. So next point is Q by M ratio of H2 gas. Yeah, tell me.
What's about you're looking for in your science?
Charge by mass ratio of anode rays was found
Sound,
to
okay,
be to be dependent on the gas used. Next is charge to mass ratio of H2 gas was found to be maximum. Okay, MX maximum. Meaning H2 is lightest gas. Hydrogen is lightest gas. Until here. Are you guys until here?
Yes, sir.
Yeah, I don't no need to raise hand. You guys are writing with me, no need to raise hand. Third point is discovery of neutron. Discovery of neutron. Okay. Now, this was discovered by Chadwick. Very less points in the discovery of neutron. Discovered by Chadwick. And the only thing that you need to know about this neutron is that why it was so late. Okay. This was very late as neutrons are not charged particles. And therefore, it is difficult to detect them. Difficult to detect them. So they were always like initially maybe some neutrons were also escaping out in the cathode ray experiment itself, in Thomson's cathode ray experiment. We were not able to detect it because they were not charged, and if they are not charged, they will not be carrying electricity, or they will not be having any type of charged. Like whenever there is charged particle moving and it strikes zinc sulfide, then the zinc sulfide is going to glow. But it was not charged, so the zinc sulfide will not glow. So we did not know whether it is moving or not, and if there is any particle or not particle. Okay. So the only thing about neutron that you need to remember is that it was discovered by Chapman. Okay. As we move on, like electrons was the easiest part. Okay. That is why I will give you a bit more detail about like the charge to mass ratio for electron, how it was and everything. Then you have protons. It is a bit difficult to explain. Then you have neutrons. It is even more physics involved in it. ठीक है? So I will explain you the electrons one. उसके बाद अगर हिम्मत बचेगी आपकी तो आप प्रोटॉन न्यूट्रॉन का सुनिएगा. ठीक है? Right till here. This is the only part about discovery of electron, protons, and neutrons that you need. Then we are going to write the models of atom. ठीक है? Write the next part. Models of atom.
You can scroll up.
Yeah, sure.
Done, sir.
Models of atom. The first one is Thomson model that we have already discussed. We are only going to discuss the drawbacks from Thomson model. ठीक है? Number one, Thomson model. Thomson's model. The drawbacks I will write drawbacks or limitations. The first drawback is it is a static model. And does not talk about motion of electron in an atom. Okay, by the way, all the drawbacks, no, whatever drawbacks we say about a particular model, it is only after we have discovered a new model. Okay. It is only after we have discovered something about electron that Thomson model cannot explain. So when the Thomson model was given, it did not have any drawbacks. Okay. When Thomson gave the model with his experiments and everything, it did not have any type of Sir, is the shape look like watermelon or just like a watermelon? What is the difference between the two statements? Is the shape look like watermelon or just like a watermelon? See, just लिखा है दो बार आपने. कहना क्या चाहते हैं आप? Zainab? Yes, it looks like watermelon. It looks like watermelon.
Yes.
Okay. So it is a static model and does not talk about the motion of electron. Because motion of electron was later on discovered, and that is why we said that Thomson did not discuss that. Second part is it does not talk about stability of atom. So how the atom is stabilized with positive and negative charges. It did not talk about the stability. Okay. Next that we are going to discuss is the Rutherford model. No, Rutherford model. Second one is Rutherford model. Right? अब इसके बारे में जरा we will discuss. I hope you have written this down. Let me know if you have not written this down. I hope you have written this down. So I am putting up a picture. Then we will explain that picture. Now, there are too many things going on. Okay, but I will explain you bit by bit. Don't look at the complete picture. Look wherever I am pointing you guys. Okay. So एक काम करते हैं. Can you see this red part? Whatever I am drawing.
Yes, sir.
Yes or no? Okay. So we will first of all focus on this box. Everything is happening here. Okay. We are going to originate from here. What happens? Here we are going to keep a radioactive source. Okay, radioactive source. It is going to give you a beam of alpha rays. What are alpha rays? These are helium, the nucleus of helium. Okay, what is alpha particle? Helium ka nucleus. So helium nucleus will have only helium, and helium has how many electrons? 2 electrons. So helium alpha particle will have helium 2 positive charge. Okay, so this is alpha particle. A positively charged, we will say that a positively charged particle. That is, forget whatever it is. Alpha particles, positively charged particle. Now we had a lead screen with a slit, like a very small slit here. And lead screen was used because if there is any extra alpha particle, the lead screen has a property that it will absorb the extra alpha particles and either the ninja. Okay, it is not going to reflect back here and there. Lead, it is going to absorb it. Now we will pass through the lead. Lead ko chhod diya. Now once we pass through the lead, we reach a gold foil. Now the gold foil that he took, it was very thin gold foil. जैसे aluminium foil होता है ना, उसी तरह का gold foil. Make sense? Yes or no? Please tell me. What is? I hope all of you have seen aluminium foil, right? Make sense, right? And we had now gold foil. Now when it was passed through the gold foil, movable fluorescent screen. I hope you can see that. What is this? Movable. If I say this will be zinc sulfide, because alpha particles are charged positively particles, and we kept a zinc sulfide, a screen which was coated with zinc sulfide, and we saw a lot of green spots. Okay, we saw a lot of green spots. I mean, a lot of means a lot of green spots. Many green spot was seen. Okay, in this A situation, this point we will call as A. What happened now? Let us suppose we got here rays which were approximately, let us suppose 10,000, 10 to the power 4. So the experiment, it was not done by Rutherford, by the way. Rutherford only gave the idea about experiment. The student was, I guess, Geiger was one of his students. जो Geiger counter है, जिसके ऊपर X-rays. I think Geiger was one of his student, and one other student was there. Those two were doing the experiment. So they found out that most of the alpha rays are striking this particular screen. That means they are passing through the gold foil easily. But just to make sure, they shifted it from A to B. Okay. What they did, they shifted the zinc sulfide coated screen from A to B. And what in every 10 minutes, 20 minutes, a green spot is observed. It is not observed as constantly as in this particular screen at the A position. In the B position, we are getting some green spot, but after a bit of time. So they did not stop there. Then they moved a bit. So as an A से सीधा B चले गए, they would have moved slowly like this. They reached B. Okay, so we are just showing that from A to B. Similarly, they start moving the slit. Sorry, they start moving the screen slowly towards the C point. Now at C, if you see the C, if you see, oh my god, at the C position is even behind the gold foil. Can you see that? Yes or no? Please tell me. Here we have the gold foil, and the C position is even behind the gold foil. Can all of you see that? Yes or no? Please tell me. Yes or no?
Yes, sir.
Can you see that? So it was really not expected. I mean, they just kept it here to check, but it was not expected, because when you are striking the gold foil, so it is going to either go outside. But what they saw was at the C point also, we are getting some green spot, but we have to wait a minute. In every 30 minutes, we see one green spot. Every 30 minutes, we see one green spot. Now, from these observations, they concluded a few points about the structure of atom. बहुत आसान है समझना आपके लिए. If I tell you, let me do something. Please. I have a something like this. Okay, this is a sphere, and inside this, I'm going to keep a small triangle. Okay, I'm going to keep a small triangular mirror. Okay, this is going to be a mirror. And in another case, in another situation, I'm going to keep a small sphere again. Inside the sphere, I have small sphere. This is also again spherical mirror, not lens. Okay, it is a mirror. Mirror क्या करेगा? Reflect करेगा. And I strike a light here like this. So the light will be struck here, and it will give some kind of deviation. And this deviation, if I strike a lot of light here, then you can at least tell about this particular surface that it is slant. If I strike light on the spherical one, then it is going to give you reflections in some different type of orientation. Does that make sense? Yes or no? Tell me. The reflections produced by this triangular type of mirror and the reflection produced by this spherical surface will be different. ये सारा का सारा क्या करेगा? वो this will happen ना? Correct है? ऐसे ही कुछ होगा? Yes or no? Please tell me guys. या फिर ऐसे होगा? है ना? So from these observations, even if I hide it, now अब हम क्या करते हैं? Let us suppose we have hidden it, but only through the reflections that is produced, you can get an idea what type of mirror is inside this particular hidden area. ठीक है? Black box के अंदर क्या है? So by those observations only, what they said was, see, because most of the alpha rays are passing through the gold foil. Please listen to me. This is very important. Okay? I will write this down, but listen to me. Since all the alpha rays are passing through the gold foil without any reflection, most of them are striking at position B. It will, what does it mean? It means that most of the atom is vacant space. मतलब वहां पे कुछ है ही नहीं. In order to create a barrier for the alpha rays. That is why all the alpha particles, most of them, they are passing through the gold foil without any deflections. Next, what they saw, some alpha rays got deflected from the path. Now, deflection can only happen, please try to understand that, deflection can only happen if it is a positively charged thing. If the deflection could only occur if it is a positively charged particle. If it was negative, वो तो deflect नहीं करता, वो तो attract करता. It is deflecting only because alpha rays are positive and it reaches something which is positive and then it gets deflected. Does that make sense? Yes or no? Please tell me. हाँ जी बताएं. The deflection can only be caused by a positively charged particle. Is that clear? Yes, no. Because alpha rays are also positive. So this positive will be deflected by a positively charged particle. Next thing is that means meaning atoms have positively charged nucleus, we say, because it is very small. Most of the atom is vacant. Next thing is that very few alpha rays bounced back. Now please understand, there are two situations I'm treating. I have, this is my atom. This is my atom. And let us suppose we have this big nucleus. The nucleus was this big. If the nucleus was this much big, then most of the alpha particles would have bounced back. Correct है? Yes or no? Please tell me. है ना? अगर इतना बड़ा न्यूक्लियस होता, then most would have, like, आप समझिए तो, if the alpha rays are striking here or here or here or here or here or here or here, all of the, like, यहाँ पे strike करता, then it would have got deflected. But all of these, at least these alpha rays would have bounced back. But it did not happen. Very few alpha particles bounced back completely. मतलब पूरा 180 degree घूम गया. What does that mean? It means that the size of nucleus is going to be very small. Size of nucleus is going to be very small. That is why most of the alpha rays are going to pass away. And some are going to get deflected. and very few are going to, ये इधर वापस हो गया, ठीक है, some are going to get deflected, यहाँ से ऐसे और डिफ्लेक्ट हो गया, यहाँ से भी गया तो ऐसे करके यहाँ से वाला डिफ्लेक्ट हो गया, ठीक है. So as the alpha ray get closer to the nucleus, it starts getting deflected, and when it hits the nucleus, it is bounced back. Okay, so that would mean if most of them is passing as it is, and then more of them is getting deflected, very few is getting bounced back. That means the size of nucleus is very small. I hope all of you understood these points. Again, I will give you 5 seconds to take a screenshot of this particular picture, but I will write each and every point, whatever observation and conclude. Okay, so I will wait 5 seconds. 5, 4, 3, 2, 1, and 0. Okay, so I will start writing observations, and then I will write what is the conclusion from that observation. The first observation was on the A position, which was most of alpha rays passed through.
So this is at least space to the diagram.
वो आप क्या कैसे अपना आवाज ठीक करते हैं सभी, हाँ उसको ठीक कर लीजिए माइक को.
So data से camera.
I still could not understand. What are you saying?
So can you hear now?
Yes, but अच्छी नहीं आ रही सही से आवाज अभी, हाँ? क्यों सही से नहीं आ रही?
Go the diagram. There's a least space to the diagram.
Can anyone understand Sabiha, or is it only me who cannot understand? Can anyone understand Sabiha? What is she saying, Muniba, Shaima?
So she's
Can you understand?
Sir, she's not properly audible.
एक आदमी कोई बोले, एक आदमी बोले, मुनीबा बताएं. हाँ.
I guess she's saying to show the diagram. She's asking if she needs to leave space for the diagram.
हाँ भाई, और क्या स्क्रीनशॉट फोन में रखने के लिए है क्या सिर्फ? स्पेस फॉर द डायग्राम, ठीक है. बट मतलब आप डायग्राम के लिए डायग्राम्स को रख लीजिए, ठीक है ना. इट्स नॉट दैट यू हैव टू मेक ईच एंड एवरीथिंग. थोड़ा एक सस्ता वाला डायग्राम भी आपको दे देंगे, ठीक है ना. डोंट वरी अबाउट. थ्रू द डायग्राम यू कैन रिमेंबर मेनी थिंग्स. दैट इज मोस्ट ऑफ द अल्फा इज पास थ्रू गोल्ड पे. लीव द स्पेस, बट लीव द स्पेस. सस्ता वाला रहेगा लेकिन स्पेस तो छोड़ना. सस्ता इन द सेंस इट विल बी नॉट एज कॉम्प्लिकेटेड एज इट इज ड्रॉन हियर. हाँ, I was saying most of alpha rays pass through gold foil without any deflection. What does it mean? Meaning most of the atom is vacant space. Okay, so this was happening in the A position. The B position, what was happening? Some alpha rays got deflected from their power. It would mean meaning atoms have positively charged nucleus. At the C position, what happened? At the C position, very few alpha rays bounced back. Bounced back. It would mean what? Meaning nucleus of atom nucleus of atom is very small, is very small and dense, and dense. बाउंस बैक तभी करेगा अगर वो बहुत ज्यादा डेंस हो, है ना? इफ इट इज नॉट डेंस देन इट विल नॉट बाउंस बैक, तो फिर मतलब न्यूक्लियस को तोड़ के निकल जाएगा अल्फा। ठीक है, बस एक छोटा सा पॉइंट यहाँ पे लिख लीजिए, आपको याद रहे, अल्फा रेज आर हीलियम न्यूक्लियस। ठीक है, इस तरह से इसको आप याद रखिएगा, डिटेल अब आपको हीलियम न्यूक्लियस से मिल जाएगा। हीलियम न्यूक्लियस में क्या होता है, देयर आर टू प्रोटॉन्स एंड टू न्यूट्रॉन्स, टू प्रोटॉन्स एंड, आपके पास दो प्रोटॉन होगा हीलियम में, एंड देयर विल बी टू न्यूट्रॉन्स इन द न्यूक्लियस ऑफ हीलियम एटम। ठीक है, अल्फा रेज दे हैव टू प्रोटॉन्स एंड M0 है, देयर इज नो इलेक्ट्रॉन। अच्छा, वो सस्ता वाला आप लोग को हम बता देते हैं, ड्रॉ कीजिएगा। ये सस्ता वाला है, इसको आप ड्रॉ कर सकते हैं, है ना? यहाँ पे भी आप तीन केसेस कर दीजिएगा, दिस विल बी ए पॉइंट, दिस विल बी योर बी पॉइंट एंड दिस विल बी योर सी। ठीक है, इसको भी देख लीजिए। Now just give me a second. I'm looking for a cathode ray diagram which is going to help us understand the charge by mass ratio on a part. ठीक है, अब आप लोग टॉपिक डाल दीजिए, डिटर्मिनेशन ऑफ चार्ज टू मास रेशियो। डिटर्मिनेशन चार्ज टू मास रेशियो। ठीक है, थोड़ा सा एफर्ट लगाएंगे तो आप लोग समझ में आ जाएगा। ठीक है, जस्ट गिव मी सेकंड, जस्ट गिव मी सेकंड। What we did today, so from the मॉडल्स ना, थॉमसन मॉडल पहले था, उसके बाद फिर आपके पास रदरफोर्ड मॉडल है, उसके बाद फिर आपका बोर मॉडल आने वाला है। ठीक है, so these are the three models that we studied, models of atoms of the, ठीक है, ध्यान दीजिएगा। ठीक है, डिटर्मिनेशन ऑफ चार्ज टू मास रेशियो, यहाँ पे दिस वन, इसमें बस एक मिस्टेक है बाय द वे। ठीक है, दिस इज आल्सो द डायग्राम शोन इन एनसीईआरटी, बस यहाँ पे मिस्टेक थोड़ा सा ये है दैट दिस शुड नॉट बी नॉर्थ, दिस शुड बी साउथ। उल्टा दे दिया था, तो एनसीईआरटी में है ये, I don't know why they are not correcting this. Yeah, this should be your, this will be north. This will be your north, and this will be your south. उतना फर्क नहीं पड़ने वाला. Let us try to understand this particular experiment. और यहाँ से हम लोग कुछ physics करेंगे. ठीक है, ध्यान सुनिए का. You don't need to write anything. You didn't draw anything. Just let me know if you are not able to understand a particular point. So first we have cathode. Cathode is connected to the negative terminal. Anode is connected to the positive terminal. So from the cathode, there will be some rays which will originate, and as you can see, ये disk type का है, उसमें बीच में एक छेद है, जहाँ से कुछ electron pass हो जाए. Now, when the some electron will pass, let us suppose that we don't have this, what we can say, ये आपका positive और ये negative वाला जो, these are by the way, इसको ऐसे करके आप connect कर दीजिए किसी power source से, and that is it. ये positive, positive, negative, positive, negative, positive, negative, ठीक है. So as a power source से ये connected, this is going to create an electric field, positive or negative, it's going to create an electric field. अब ध्यान दीजिए जरा. Let's suppose that electric field is not here, है ना. अभी हम इसको ऐसे कर देते हैं. The key is not, अभी connected नहीं है, ठीक है, it's not connected right now, and we don't have this magnet also, that north south magnet जो भी यहाँ पे लिखा हुआ है, वो भी हमारे पास अभी नहीं. So when nothing is there, then what's going to happen? The electron, it is going to move and it is going to strike the B section. The B position it is going to strike by the electron because there is no deflection. Any deflection होने के chance ही नहीं. B point. अच्छा. What will happen if we are going to attach this electric field? जैसे आप electric field attach करेंगे यहाँ पे, तो because it is a negatively charged species, तो negative वाला positive की तरफ attract होगा, है ना? That makes sense, yes or no? कि आपके पास इलेक्ट्रॉन है. इलेक्ट्रॉन कैसे पता चला? Because it is passing through the anode. Anode positive charge है. तो ये जो इलेक्ट्रॉन है, now also it is going to get deflected and it is going to strike on the A position. When we are going to attach this particular electric field, यहाँ तक समझ में आया सबको? Yes or no? Please tell me. Does this make sense? Yes or no?
Yes.
Yes ना? ठीक है. अच्छा. Now, if it is getting deflected, अब किसी भी चीज का अगर आप किसी भी चीज का अगर डायरेक्शन चेंज करेंगे, if you direction something moving and you are changing the direction, that means you are changing the velocity. You can change velocity when you exert a force. That means there is some force acting on this particular electron. तो ये चीज आप 12th में पढ़िएगा जो फॉर्मूला है इसका. This electron, it is going to have some charge. ठीक है. So this is going to get upward force. यहाँ पे एक upward force लगेगा. I think I should do something. एक दूसरा पे यूज करते हैं. Black would work. Black is working fine. There will be an upward force on the electron. The magnitude on this particular, this force magnitude, it will be the charge on electron and the electric field. इसलिए भी मतलब थोड़ा conceptually आप समझ लीजिए कहाँ से आया फॉर्मूला. जितना ज्यादा चार्ज होगा उतना ज्यादा पॉजिटिव वाला टर्मिनल, it is going to attract that charge. And if I have a highly positive terminal because of high electric field, then also the positively charged, then also the negatively charged electron will be attracted more intensely. दो चीजों की वजह से it is going to be attracted more intensely. If the charge itself it is very high of the electron, or the particle it is attracted by a higher electric field. ठीक है. तो I hope that makes sense कि force दो चीज पे डिपेंड करेगा. Make sense till here? Yes or no? Please tell me that this force will be equal to Q into E. Yes or no?
Yes, sir.
ठीक है. Next what we will do now, next what we did, then we added a magnetic field. How did we add a magnetic field? By putting up a magnet. Now we adjusted the magnetic field and we adjusted the position of the magnet such that this particular electron, it started experiencing a force in the downward direction. So now if it is experiencing force in a downward direction, आप ये रूल लगा के देख सकते हैं. What was the rule in the 10th standard? क्या रूल होता था? That gave FBI करके होता था ना? If you remember. So the force B is what? This is the direction of the magnetic field. I is the direction of the current. I के अपोजिट करना पड़ेगा because electron is moving and the, तो आप अगर ये कीजिएगा then you will get it कि downward force लगेगा. ठीक है. But इतना तो कम से कम कर सकते हैं. दो ही तरह से force लगता है, upward और downward. We adjusted the magnetic field such that it is getting downward, and so much so we applied so much magnetic field that the electron which was on the A position, it came back to the B position. When this happened, then we can say that whatever force was applied by the electric field, that is equal to QE, will be equal to the force applied by magnetic field. The force applied by magnetic field. अब ध्यान सुनिएगा एक बात. When we apply magnetic field on current carrying conductor, then only a force is exerted. Correct? Yes or no? Please tell me. The conductor should be carrying current. If the current is not carried by the conductor, then it is not going to exert any force. Correct है? Yes or no? याद है कुछ टेंस से?
Yes, sir.
ठीक है. Now, if something is carrying current, that means there is flow of electron. That means we can say the force that is exerted by the magnetic field will depend on the movement of the charge particle. Movement means the velocity of the charge particle. If velocity is equal to 0, the force will become 0. That means velocity should also be in the force formula, and that is true. What happened? The formula for this is ये सारी चीजें 11th में 12th में पढ़ने वाले. But I will tell you something कि charge होना चाहिए. तो क्यों लिखते हैं? The force, the magnetic field से जो force आ रहा है Q, velocity होना चाहिए. That is by velocity multiplied by the magnetic field. जो भी magnetic field है, जितना ज्यादा magnetic field होगा उतना ज्यादा force भी लगेगा. So the force applied by the magnets or the magnetic field will be equal to Q into V. V is the velocity into B. B is the magnetic field. This is the force applied by, this is force on downward direction. Does that make sense? Till here, yes or no? Please tell me. ओहो, दो चीजें समझ में, QE और QVB. बताइए गाइस, yes or no? यहां तक समझ में आया सबको? ओह, समझ में आया क्या? Oh my god. Yes, tell me guys, did you understand these things, that upward force is QE, downward force is Q into V into B. B is the magnetic field.
Yes, sir.
Yes. And since the charge particle that we have, the electron, it is not moving, that means both of these will be equal. Then only it is balancing the forces are balanced. That is why there is no deflection. So I can say, what I can say, Q, whatever the charge on whatever the charge on this charge particle, we do not know that it is electron. Electron नहीं, electron तो पता है, electron नाम देते हैं. जो भी charge हो उसके ऊपर, it is ये force, upward force is equal to the downward force. Downward force क्या है? Q into V into P. ठीक है, अब ध्यान दीजिए जरा. Q से Q कैंसिल हो जाएगा. V जो आएगा, velocity of the electron will come out to be what? E by B. Who is applying electric field? I am applying electric field. So I will know how much electric field I am applying. Who is applying the magnetic field? I am applying the magnetic field. I am using the magnet. So I will know what is the magnetic field of the magnet. I know E, I know B. Now I can calculate the velocity of electron. Electron, which is a microscopic atomic level particle, उसका velocity हम लोगों ने macroscopic measurement से निकाल. Can you understand how we got the velocity? Yes or no? Please tell me. बताइए guys. तो आया ना तो बोलो, समझ में आया नहीं आया? Yes, ठीक है. लेकिन अभी तक तो काम खत्म नहीं हुआ ना. What we need, हम लोगों को क्या चाहिए यहाँ पे? हम लोगों को चाहिए चार्ज बाय मास रेशियो. वेलोसिटी आ गया, वेलोसिटी इज गोइंग टू बी यूज्ड. अब थोड़ा सा हम लोग आगे बढ़ते हैं. ठीक है, ध्यान दीजिए. अच्छा, इफ वी आर यूजिंग अ पॉजिटिव प्लेट यहाँ पे ना, तो इसका तो हम लोग को ये भी पता होगा द डिस्टेंस, मतलब बिकॉज वी आर यूजिंग दिस, मतलब हम लोगों ने लगाया है. जो भी मैन्युफैक्चरर रहेगा ना, दैट दे विल गिव यू दिस पर्टिकुलर विड्थ आल्सो, और यू कैन मेजर इट आल्सो दिस विड्थ. अब इसी विड्थ से थोड़ा सा काम करना है हम लोग को. ध्यान दीजिएगा, ठीक है, ध्यान दीजिएगा प्लीज. Let us suppose I am drawing that plate here, and ये पॉजिटिव वाला टर्मिनल है और ये आपका नेगेटिव टर्मिनल है. ठीक है, इस द नेगेटिव टर्मिनल. इसको हम डिस्टेंस यहाँ से यहाँ तक एक डिस्टेंस पर मान लेते हैं, दिस इज x. ठीक है, दिस इज द डिस्टेंस x. अब what happened to the electron? The electron came and it had to pass like this. पहले तो ऐसे ही पास कर रहा होगा by the way. And ग्रीन से रिमूव कर देते हैं. Then I will put some dotted lines. Approximately यहाँ कहीं से इसका डिफ्लेक्शन स्टार्ट हो गया, right? When we applied the positive negative charge. So this was the path that it had to follow. मतलब जो कि उसने फॉलो भी किया था वो हम लोग यहाँ पे आगे जाके उसको पॉइंट कर लेंगे. And what happened after deflection, वो भी देख लीजिए जरा. सो आफ्टर डिफ्लेक्शन बहुत अच्छे से बनाते हैं ना, ऐसे बहुत अच्छे से बनाते हैं, आप लोग को दिखा दें। सर ये क्या बन गया सर, ध्यान से देखते रहिए बस। ग्रीन कर देते हैं। कुछ इस तरह से डिफ्लेक्शन होगा, देखिए कितना अच्छा बना है ना। ऐसे कुछ डिफ्लेक्शन होगा, ये सुनो टेल मी गाइस, बोलो भाई इतना अच्छा बनाया हमने, बताइए ऐसे ही होगा ना डिफ्लेक्शन।
Yes, sir.
ठीक है, अब ये डिफ्लेक्शन जितना हो रहा है ना, इसको हम लोग को थोड़ा सा कैलकुलेट करना है, इस वाई डिस्टेंस। अभी क्या कैसे वाई डिस्टेंस आएगा, बहुत आसान है ना, फिजिक्स आप लोगों ने पढ़ रखा है, ठीक है, 9th क्लास की फिजिक्स है, तो इस्तेमाल होना चाहिए। ठीक है, तो ये जो डिफ्लेक्शन है ना, डिफ्लेक्शन कितना हो, ये वाई डिस्टेंस हम लोग को फाइंड आउट करना है, ठीक है, ध्यान दीजिएगा। लेट मी गेट दिस सम डिफरेंट कलर, इसको ब्लू ही कर देते हैं, ब्लू विल गिव, ठीक है, तो दिस दिस एक्स, इसको बोल देते हैं हम लोग वाई। अच्छा, व्हाई देयर इज डिफ्लेक्शन, बिकॉज अ फोर्स इज अप्लाइड, फोर्स कौन सी डायरेक्शन में पड़ रहा है, अभी सिर्फ और सिर्फ वी आर हैविंग द इलेक्ट्रिक फील्ड, तो फोर्स विल बी अप्लाइड इन द अपवर्ड डायरेक्शन, ठीक है, अपवर्ड एक फोर्स लग रहा है, वी हैव अप्लाइड अ अपवर्ड फोर्स, ओके। कितना अपवर्ड फोर्स लग रहा है वो तो अभी हम लोगों ने देखा था ना, F इज इक्वल टू वट एवर द चार्ज ऑन दैट पार्टिकल मल्टीप्लाइड बाय द इलेक्ट्रिक फील्ड, इतना ही तो अपवर्ड फोर्स लग रहा था, ठीक है। अच्छा, आप लोगों को पता है F इज इक्वल टू एम ए, पढ़ा अभी आप लोगों ने फिजिक्स में, F इज इक्वल टू एम ए, नहीं पढ़ा है? न्यूटन्स लॉज ऑफ मोशन में F इज इक्वल टू एम ए, स्कूल में कहीं तो देखा होगा F इज इक्वल टू एम ए, नहीं, टेल मी गाइस, F is equal to ma you would have learned in 9th standard only, अभी फिजिक्स की क्या बात करें, in 11th you use it very much, but F is equal to ma we have learned it ना, yes or no, please tell me guys।
Yes, sir.
हाँ ठीक है भाई, ये सर बोले, ठीक है, so what we can say, ध्यान दीजिए, F is equal to ma पुट करेंगे, acceleration हमारे पास आ जाएगा for the particle, acceleration will be equal to whatever the charges, whatever the electric field is, यहाँ पे m था उसको डिवाइड कर दिया m से, आप लोगों को दिख रहा होगा q by m आ चुका है, चार्ज बाय मास, कैन यू सी दैट गाइस, yes or no, please tell me।
Yes, sir.
ठीक है, अब ध्यान से देखिए जरा, ये जो हॉरिजॉन्टल डायरेक्शन एंड देन वी हैव अ वर्टिकल डायरेक्शन, ठीक है, काइनेमेटिक्स आई होप शायद स्टार्ट हुआ, आई डोंट नो, हॉरिजॉन्टल डायरेक्शन में द स्पीड विल बी सेम एंड देयर इज डिफ्लेक्शन इन द, देयर इज डिफ्लेक्शन इन व्हाट, इन द ये डायरेक्शन ना, वाई डायरेक्शन, ठीक है, एक्स डायरेक्शन में जो कोई डिफ्लेक्शन नहीं है, वाई डायरेक्शन में डिफ्लेक्शन, तो वी कैन राइट कि स्पीड जो होता है दैट इज इक्वल टू एक्स डिस्टेंस डिवाइड बाय टाइम, ऐसे ही तो होता है ना, whatever the velocity is, so I can write this x is equal to वेलोसिटी इनटू टाइम, क्या ख्याल है बताइए गाइस, ये x तो हम लोग को पता है बिकॉज दिस इज द इलेक्ट्रो, दिस इज द प्लेट ऑफ दैट प्लस ये वाला है ना, इसको तो हम लोग मेजर कर सकते हैं, वी कैन कैलकुलेट व्हाट इज दिस x, और v जो है वी हैव जस्ट नाउ मेजर्ड द वेलोसिटी ऑफ द इलेक्ट्रॉन, v इज इक्वल टू e बाय b, तो हमारे पास यहाँ से आप एक चीज ये देख सकते हैं कि हमारे पास, इसको हमको लिखने की जरूरत ही नहीं थी बाय द वे, वी एक्चुअली नीडेड द t ना, तो t इज इक्वल टू लिख सकते हैं, see this speed is equal to distance by time, I want to calculate how much time is taken for the electron to move through this particular metallic plate of x length, so I can say that time will be equal to x that we can measure divided by v that we have already calculated, बात समझ में आ रही है, सुनो पीछे गाइस,
Yes, sir.
Yes,
अब
sir.
ध्यान से सुनिएगा, now it is going to be very important, ठीक है, when the particle was here तब तो y डायरेक्शन में देयर वाज नो मूवमेंट ना, until unless it entered that electric field there was no movement, there was no velocity in the y direction, is that clear, yes or no?
Yes, sir.
Yes,
ठीक है,
sir.
अब ध्यान से सुनिएगा जरा, that means we can say, so here if I say about the y direction, we are not talking about the y direction, initial velocity is 0 and I will apply the second equation, u s is equal to ut plus half at square, s is equal to ut प्लस हाफ at स्क्वायर। ध्यान दीजिएगा, आई एम इन द वाई डायरेक्शन, एक्स डायरेक्शन में हम लोग नहीं है, सो वी आर नॉट गोइंग टू टॉक अबाउट एनीथिंग अबाउट द एक्स डायरेक्शन। दिस वेलोसिटी दैट वी हैव पुट, दिस इज फॉर द एक्स डायरेक्शन। इनिशियली जब यहाँ पे था तो वहां पे कुछ भी वेलोसिटी वाई डायरेक्शन में नहीं था। दैट मीन्स, ये सही लिखा है हम लोगों ने, हाँ, दैट मीन्स दिस u will be equal to 0 because initially कोई भी velocity नहीं था। what is this s? s is the distance that is traveled in the y direction, तो ये y है, तो I will write here y। s की जगह क्या लिखेंगे हम? y लिखेंगे। ut तो 0 हो गया, it is equal to हाफ at स्क्वायर। a भी हमारे पास, देखिए अब a तो छोड़िए, हमारे पास नहीं है, बट आई हैव अ फॉर्मूला फॉर a क्या हो जाएगा, तो ऐसे लिखते हैं यहाँ पे y it is equal to half, अच्छा y is equal to half at स्क्वायर, समझ में आया सबको? yes or no, please tell me guys, y is equal to half at स्क्वायर, बोलिए।
Yes,
हाँ
sir.
ठीक है। सो y is equal to half, a की जगह क्या लिखेंगे, वॉट एवर द चार्ज, वॉट एवर द इलेक्ट्रिक फील्ड डिवाइड बाई वॉट एवर द मास इनटू टी स्क्वायर। टी की जगह क्या लिख सकते हैं हम लोग, एक्स स्क्वायर बाई वी स्क्वायर। ठीक है, एक्स स्क्वायर बाई वी स्क्वायर, दैट मेक सेंस? yes or no, please tell me guys, यहाँ तक
Yes, sir.
ठीक है?
Yes.
अब ध्यान दीजिए जरा, यहाँ से व्हाट वी कैन डू, वी कैन डू सम substitutions and क्यू है, एम है, वी हैड समथिंग फ्रॉम हियर, कुछ है क्या हमारे पास यहाँ पे, वी है हमारे पास और ई है। ठीक है, लेट अस सी, क्यू बाई एम को अलग कर देते जरा, ठीक है? तो क्यू बाई एम क्या हो जाएगा, क्यू डिवाइड बाई एम, वाई इज इक्वल टू हाफ क्यू बाई एम ई, और आपके पास क्या है, एक्स स्क्वायर डिवाइड बाई वी स्क्वायर। वी स्क्वायर के लिए भी आई थिंक वी विल सब्सटीट्यूट दैट ई बाई वी, है ना? ठीक है, अब यहाँ से हम लोग आगे, तो क्यू बाई एम जो होगा दैट विल बी इक्वल टू 2y इंटू वी स्क्वायर डिवाइड बाई ई इंटू एक्स स्क्वायर। यहाँ तक समझ में आया? ऐसा प्लीज टेल मी गाइस, ये देख लीजिए जरा, ऑल ऑफ यू अंडरस्टूड टिल हियर? यस ना? ठीक है, अब ध्यान दीजिए जरा, क्यू बाई एम इज इक्वल टू, वी की जगह हम लोग क्या करेंगे, वी इज इक्वल टू ई बाई वी था, इसी को सब्स्टिट्यूट करेंगे, 2y मल्टीप्लाइड बाई वी स्क्वायर क्या हो जाएगा, ई स्क्वायर डिवाइड बाई वी स्क्वायर, नीचे हमारे पास ई इंटू एक्स स्क्वायर पहले से ही, so I can cancel this e, I can cancel this square, the q by m will come out to be 2 into y into e divided by x square into b square. So this is how, see, all of these things are measurable, सारी चीजें, all of these things are what, all of these things are measurable, ठीक है? टू तो खैर कांस्टेंट, y इलेक्ट्रिक फील्ड हमने रखा है, b भी हमने रखा है, x भी प्लेट का डिस्टेंस है, वो भी मेजरेबल है। सो व्हेन यू कैलकुलेट ऑल ऑफ दीज थिंग्स यू विल गेट द चार्ज बाय मास रेशियो, जो कि आया था, जो कि हम लोग लास्ट क्लास में कैलकुलेट किया था। we knew the charge and we knew the mass, both of these things, and it came out to be how much, 1.7 into 10 to the power किलोग्राम में 11 into 11 कूलम्स पर ग्राम पर केजी आएगा, और ग्राम्स में अगर कैलकुलेट करेंगे देन इसमें आप 10 to the power केजी की जगह क्या कीजिएगा, माइनस कर देना होगा ना आपको, ग्राम्स नीचे है, सो 10 to the power 8 हो जाएगा फिर, है ना? yesterday we did this, no? 10 to the power 8 coulombs per gram, ठीक है, 1.7। so this is how Thomson determined the charge by mass ratio, ठीक है? this came out to be 1.7 into 10 to the power 11 coulombs per kg, और 1.7 into 10 to the power 8 coulombs per gram। चलिए प्लीज कॉपी दिस डाउन। कॉपी करना, पढ़ना है क्या, प्रोटॉन न्यूट्रॉन बताइए जरा। अच्छा, कुछ आएगा नहीं इन सब चीजों से, लेकिन बस यही है दैट थोड़ा समझाने के लायक है ये, इन फॉर अ 10th क्लास स्टूडेंट, है ना? आप तो 11th क्लास के स्टूडेंट अभी आप नहीं है, Please understand that. You are studying 11th ना. Once you have studied 11th, then you will be 11th class student. कि आपको 11th class का ठीक है 11th class के student के पास 10th class की knowledge. So it is okay to make 10th class student understand this whole thing. क्योंकि अभी अभी वो लोग करेक्ट कंडक्टर में मैग्नेटिक फील्ड लगाएंगे तो क्या होगा है ना पॉजिटिव और नेगेटिव अट्रैक्ट करती है सारी चीजें आप लोगों को पता है अभी प्लीज कीप राइटिंग लेट मी नो व्हेन आई हैव टू स्क्रॉल डाउन हाँ थोड़ा डायग्राम आप एटलीस्ट उतना कॉपी कर लीजिए जितना आपको खुद समझ में आ जाए कि क्या हो एग्जैक्टली कॉपी करने की जरूरत नहीं है ठीक है आपको मतलब बिल्कुल कैथोड एनोड वो बनाने की जरूरत नहीं है अब बस ऐसे एक लाइन पास कर दीजिए फिर उसके बाद स्केल से इतना बना लीजिए कम से कम दैट ऐसे है उसके बाद ऐसे पास हो रहा है यहाँ पे पास हो रहा है देन अपवर्ड फोर्स डाउनवर्ड फोर्स आपको आपको समझ में है ठीक है ना पूछा तो नहीं जाएगा कहीं पे भी है ठीक है ना पूछा नहीं जाएगा तो आपके अपने कॉन्फिडेंस के लिए ये सारी चीजें आपको जानना जरूरी है बट द ब्यूटी ऑफ दिस थिंग इज कि आप सोचिए जरा इस चीज को कि वी हैव नॉट सीन इलेक्ट्रॉन बट वी नो इट्स चार्ज एंड वी नो इट्स चार्ज बाय मास रेशियो चार्ज के लिए तो फिर यू हैव द मोलिकन्स एयर ड्रॉप सॉरी नॉट एयर ऑयल ड्रॉप एक्सपेरिमेंट वो भी इट इज अगेन इंस्ट्रूमेंटेशन का पीक है मोलिकन्स ऑयल ड्रॉप एक्सपेरिमेंट लाइक how the complete experiment was done in order to calculate the charge on electron. That is unthinkable. No? कि electron दिखता भी नहीं but we can determine its charge by the power of experiments and the power of formulas I would say. Calculation से हम लोग क्या कर सकते हैं we can get the charge. So what the charge on electron is not directly measured, it is rather indirectly measured with the use of calculations and everything. Okay. Now, obviously, it seems this experiment is very easy to understand. The काफी आसानी से हमने इसको समझा तो दिया, but it is quite hard to do the experiment. And when you do the experiment also, no, you do not get exact value as we have got as 1.7 in every cases because एक चीज के बारे में जो हमने बिल्कुल बोला ही नहीं, जो जब आप एक्सपेरिमेंट करने जाएंगे तब आपको पता चलेगी चीजें. For example, Earth also has its magnetic field. So you have to set this whole thing in such a way कि अर्थ का मैग्नेटिक फील्ड आपके एक्सपेरिमेंट को डिस्टर्ब ना करे ठीक है सो देन यू हैव टू गेट अ कंपास उसको नॉर्थ साउथ डायरेक्शन बिल्कुल प्लेस करना रहता है एंड द कंप्लीट इंस्ट्रूमेंट्स आर वेरी इसमें एटलीस्ट कितने इंस्ट्रूमेंट लगते हैं पता है एक तो कंपास लगता है, इन जनरल वाला एक कंपास लगता है। देन एक तो सीआरटी लगता है, दिस इज द कैथोड रे ट्यूब, है ना, और द डिस्चार्ज ट्यूब। एंड देन तीसरी चीज लगती है, देयर इज अब वुडन, क्या बताएं इसको कैसे यार, ऐसे करके एक वुडन बॉक्स टाइप का होता है, ऊपर से खाली रहता है, ठीक है। एंड हियर यू हैव स्केल, हियर आल्सो यू हैव स्केल, एंड हियर एक्चुअली वी पुट मैग्नेट्स, ऐसे मैग्नेट यहाँ पे रखते हैं, उसको मैग्नेट को मूव करते हैं, so that that particular that particular cathode ray, it comes back to the original point। तो ओरिजिनल पॉइंट भी पहले मेजर करना पड़ता है कि कहाँ पे है, ठीक है। उसके बाद फिर डिफ्लेक्शन होता है, डिफ्लेक्शन का मेजरमेंट लेना, कहाँ पे डिफ्लेक्शन हो रहा है, काफी कैलकुलेशंस लगते हैं इसमें। थ्योरेटिकली आसान है, बट एक्सपेरिमेंट से सारी चीजों को मेजर करना इट इज वेरी डिफिकल्ट। हाँ, ये एक्स वगैरह ये सारी चीजें आपको दी हुई फ्रॉम दिस कैथोड रे, है ना, इसी में से आपको जो मैन्युफैक्चरर है वही दिया रहता है कि जो प्लेट का लेंथ है वो कितना होगा, ठीक है। तो आई होप इसमें ज्यादा लिखने का नहीं था, आई होप यू हैव डन दिस। यहाँ से आपको कॉपी कर लेना जरा, फिर हियर।
Done, sir.
If you're done, so if you're done, can you please check the Learnivio app? There will be an assessment activated. असेसमेंट में ये सारी चीजें कुछ भी नहीं है, ठीक है। वेरी बेसिक असेसमेंट ऑन द मॉडल्स ऑफ।
No, sir.
देयर इज नो असेसमेंट।
So it's there.
इट्स देयर ना। इफ इट इज नॉट देयर देन प्लीज मैसेज Learnivio, ठीक है। प्लीज मैसेज Learnivio if it is not there, okay। चलिए, वो अभी के लिए बाय। Sorry, you did not finish writing. It's you write it.